It tells us that Brett and Meredith play a price competition game, and the one-shot version of this game is represented by the normal form below. So remember our rules about one-shot games and how we solve them. It says, what is true of the Nash equilibria of this one-shot game? Well, first let's go through and solve. We say, well, Brett thinks if Meredith plays aggressive, I'm comparing 0 to negative 10, I'd rather have 0. If Meredith accommodates, I'm comparing 5 to 10, I'd rather have 10. So if Meredith plays aggressive, I'm going to be aggressive. If Meredith accommodates, I'm going to accommodate. Well, Meredith does a similar process. She says, if Brett is aggressive, I'm comparing 0 to 10, I'd rather have 10. And if Brett accommodates, I'm comparing 20 to 15, I'd rather have 20. So Meredith is going to accommodate if Brett is aggressive, and Meredith is going to be aggressive if Brett accommodates. So what we see is there's no pure strategy Nash equilibria. A says there are none, and they're talking about Nash equilibria in general. So just because there are no pure strategy Nash equilibria does not mean there's no Nash equilibria. So A is wrong, because if A were to be true, it would have to say there are no pure strategy Nash equilibria. That is a true statement. So we can get rid of A. B says there is one pure strategy Nash equilibrium, and we know that that's false because we just saw that there are 0 pure strategy Nash equilibrium, so we can get rid of that. C says the probability that Meredith is aggressive makes Meredith indifferent between being aggressive or not. And that's not true. The probability that Meredith is aggressive makes Brett indifferent about between being aggressive or not, which is D's answer, so C is incorrect. So back to our Nash equilibria point, every game has a Nash equilibria, no matter what. Some of them have pure strategy Nash equilibria, which is 2 stars in one box, but every single game has a Nash equilibrium. Nash equilibrium is just something that happens. And if we're playing a game, something's going to happen. Now, when there's a mixed strategy Nash equilibrium, like in this game, where we're not sure what everybody will do because there's 4 stars in 4 boxes and there's not 2 stars in one box, that just means that the probability that Meredith is aggressive makes Brett indifferent between being aggressive or not, and the probability that Brett is aggressive makes Meredith indifferent between being aggressive or not. So in this kind of game, we don't know with certainty where they'll end up. We do know they'll end up somewhere, so we do know there is a Nash equilibria, and we do know that there's just a probability of each of them making a move, depending on the other person's payoffs and the other person's strategies.